Hey everybody, welcome back for another video. In this one, we are going to be talking about a topic that comes from the functional programming world, I suppose. And what we'll be doing is getting the sum of all the elements in an array. We're going to work through solutions that use a for loop, a while loop, a recursive function in JavaScript, a style of recursion that is inspired by Haskell, and then finally the way that JavaScript would prefer that you do it, which is the reduce method. I'll be making a couple assumptions in this video that the only type of value that will be passed in to my function will be an array. I just don't see the point of cluttering everything up with a bunch of edge cases and error handling. So I'll have some basic error handling, but it'll make these assumptions. And the other assumption being that the array will only contain numbers. So with that out of the way, we will work our way up into some really cool recursive functions. So starting out, here's our setup. Every single version of this solution will be using the same numbers array called nums. And it'll be the values 1 through 10, incremented by 1 without skipping any values. We'll have the output of the answer so that we can always compare whatever our function is giving you to a manually calculated result, so we can see that it's 1 plus 2 plus 3. So if anything funky happens here, they don't match, then we know there was a problem with our function. And each one will start with some sort of error base case for if nothing is passed in. So first things first, we're doing a for loop. And with a for loop, we have inside of this function called sumAll. It accepts the nums array. If there is no array passed in, it just returns 0 because the sum of nothing, in this case, we will just say is 0. Let's just say that again, another assumption for our program. And we'll set our initial sum to be 0. We're going to create a variable called I for just the for loop. While I is less than the length of the array, it will iterate through that array one at a time, and we will add sum to the current value in the array. So the first time through, we take 0, and we add it to the first value in the array, which is 1, and then sum will equal 1. And then we will add sum to the second value in the array, which is 2, so that'll be 3. And then we'll add the value of sum being 3 plus 3, which is the third value in the array, and then 6 plus 4, and so on and so on. I assume this is probably common knowledge to everybody, but if you're a little confused by what's going on here, we're starting at 0 because when I say 3 is the third number in the array, it's the third number in the array, but it's the second index because arrays are in JavaScript are indexed at 0. So this is the index of 0 is 1. Index of 1 is the value 2. Index of 3 is the value, or of 2, sorry, is the value 3, and so on and so on. So as long as it's less than the length, which is 10, then it'll keep running through, and then we return our sum. And if we run this in the terminal through node, so we go node for loop, then it'll give us our answer of 55 and the manually calculated answer of 55. So most people are probably familiar with this, but there's a long ways that we can go to solve this in more interesting ways, or at least more powerful ways for more complicated problems. Next up is the while loop. This is probably one that no one would ever tell you to use, but I think it's useful to as an intermediary step between the for loop and recursive. So for the while, I actually don't think I use the sum function in here. Oh, yes, I do. I use it once. All right, so I've created a sum function. It will be used throughout the rest of our solutions. And all it does is it takes a first parameter of num1, a second parameter of num2, and returns the value of those two added together. So it creates the sum of two numbers. We have our error handling for if nothing is passed in. And then we are asking is the array a length of 1, meaning that we only had one value passed in. If so, return just that first value, because the sum of the array at that point is just that value. If the array is 2, then we can return, and in functional programming we want functions to work for us as much as possible. We're going to return the 2 arguments that are in the array, or sorry, the 2 values in the array passed into sum. So if you're not familiar with this, this is the spread operator, and it is part of ES6 or ES 2015. And what it does in this instance is take the values in the array and separate them into 2 separate values. So it takes what would be, in that case, 1 and 2, and it makes them passed in like that. So those are the parameters that we're passing in. So it goes from sum with 1 argument being an array of 1 and 2 to having 2 arguments passed in, which are the values 1 and 2. And since there's only 2 in the array at that point, we are returning the sum of those 2 values in the array. Well, then we need to handle the other cases, which are anything that's more than 2. So if we have more than 2 values, then we have to iterate through them. And again, we'll establish an I at 0. I had to call it total because I'm using sum in this solution. So that was a naming conflict. So total equals 0. And while I is less than the array.length, which is the same thing from our for loop, we will add the total plus that value in the array, and then we will increment I by 1. And so this is just like the for loop, except all broken apart, and then we will return the total. And again, if we go node while, then we get our value of 55 and the answer, which is 55. So the reason I included this solution is because we're now introducing base cases. This is going to bother me. There we go. We're introducing base cases. So one thing that you get from Haskell, which is what we'll be leading up to, is the idea of, I don't know if they call it pattern matching, but that's how I understand it in my head. I'm by no means a pattern or a Haskell expert. And they basically say, if you have a value that, or a, how would they describe this? If you have a value that looks like this, so we create some situation and say, does the value that we're dealing with look like this? In this case, we're saying, does the array look like it has a length of 1? If it does, then this is what I want you to do. If it has a length of 2, then this is what I want you to do. And it's all based on what the shape of the value is that's passed in. And in Haskell, you need to have entirely exhaustive pattern matching in order to have a function that can perform properly, because Haskell uses a lot of recursion. So if you have non-exhaustive patterns, then you run into trouble. So that's why I'm including this one. It's introducing this idea of handling a base case. So next up, we're going to take those same base cases. And again, I'm going to have to add that there. We're taking these exact same base cases, but now we're going to do this all recursively. So we still have our sum function, and we are now passing the first value in the array and the rest of the array into the sum function. So we're taking array 0, so 1, and we are passing in as num2 all of the remaining values in the array, except we're calling it back into sum all. So if this is your first time seeing recursion, this probably makes absolutely no sense to you. We are slicing off the first value and passing it into sum all. So this is going to happen first, essentially, is what you can think of. So we have sum all passing in 2 through 10. So 2 through 10 comes in here. Is it a length of 0? No. Is it a length of 1? No. Is it a length of 2? No. All right, so let's go back here, and we'll take 2, because that's the new first value, and we'll take the rest of the array, so 3 through 10, and we'll pass that back through. Is 3 through 10 a length of 0? No. A length of 1? No. A length of 2? No. All right, so we'll pass 3 into here, and then 4 through 10 into the rest of the, or into the sum all function as the second value. And then we keep doing that until we get to the point now where we're starting to pass in 8 into here and 9 and 10 into the sum all function as the second value. Well, now the 9 and 10 come in here. Is that a base value of 0 or a length of 0? No. Is it a length of 1? No. Is it a length of 2? Yes, it is. So that means we pass 8 and 9, or sorry, 9 and 10 into sum. So that comes back. We go 9 and 10 is going to be 19. So we return 19. So now 19 comes back in, and we now have a value to add to 8. So we do 19 plus 8 is going to be 27, and then we'll take that value and add it to 7, and we'll take that sum and we'll add it to 6, because we've called these all in a row. And so we're just going to recursively add these all together until we get back to the point where we have two values, 1 and the rest of the array, whatever that sum is. We know it'll be 54 in this case, so we'll pass in sum, or we'll pass into sum the value 1 and the value 54. Those can be added together because they're just numbers, and so we get 55. So if we do node recursive, and we get 55, and the answer 55. If this doesn't make any sense, please learn some more about recursion before you really look at the next two, because you'll need to understand this. If this makes perfect sense and you're familiar with it, awesome, let's move along. So I've included this one as an example of how you might do some wonky stuff with JavaScript in order to make it look a bit more like Haskell. This is not how Haskell looks. It's kind of like how Haskell behaves. It's janky, but I think it gives us a cool idea about how we can understand what we're actually asking when we're looking at our base cases. So if we look at these base cases, we're saying if r.length equals 1. But all we need to know is, do we have one value or do we have more values? What's the shape of our data? We don't actually care what the length of the array is. The length of the array is a symptom of the fact that we only have one value. And if we have one value, then we know we can just return that one value. Or if we have two values, we know we can pass it into the sum, or the sum function. But we don't actually care what the length of array is. It has nothing to do, like the length of this array, the length of nums has no effect on what sum cares about. Sum's just sitting there waiting for two numbers to be passed in. This could be 48 things long, this could be one thing long. It doesn't really care. It just needs to know that it's going to receive two values that can be added together. So this is, if you really think about it, this has nothing to do with what our goal is. This is a side effect, and it's a indirect way of figuring out what the shape of our data is. And what Haskell encourages us to do is actually shape our data into a method, or into a format that is very explicit. Now, in Haskell, you can do this cool thing where if an array is being passed in, you can do something like this, where x is the first value in the array and xs is the rest of the values in the array. And you can split up data a lot like that. I think you can do this. Again, I'm not a super expert in Haskell, but I learned a few cool things that immediately carried over to my JavaScript understanding of base cases. And so this would be the first index, the second index, or the 0 index, the 1 index, and then all the rest of them. So this would essentially be an array. And so what we can do now that we have ES 2015, or as everybody still likes to call it, ES6, is we can use this REST operator to actually make things a lot more like how Haskell has it set up. So down here, I'm passing in the nums array like we have every other time, but I'm spreading it into individual values. So instead of being an array of 1, 2, 3, etc., it's now looking something like sum all, and it'll be 1, 2, 3, etc., like that. So I should probably do it like that with just 2 dots. So we're getting the values separated individually. So what that means is we can now go x, and x will become the first value in the array, which is 1. And then we can gather up all the rest of the arguments that are being passed in into a single array called xs. And now we can ask simply, do we have a value for x? If we don't, then we can just return 0. Because we know that if there's no first value, then there's no array at all. And so this is very explicit about what we're trying to say. Because if we don't have an x, there's nothing to do here. And likewise, if we don't have xs, then we just return x, because there's nothing to add to xs. Now, again, I believe in Haskell you write it something like this. And it would see, all right, well, if x is the only value in the array, then return x. Instead, we have to say, but the only way that we can really say is x the only value in the array is by saying, is xs not a value? Which means, does the rest of the array not exist? By de facto, we then mean x is the only value in the array. So like I said, it's a little wonky, but it's kind of cool to think about. Because down here, we can write this very, in my opinion, expressive, easy to understand code, assuming you understand the rest and spread operator, where we can pass in sum, the first value in the array, and then we can recursively call sum all with the rest of the values. And so again, just like the previous example, this runs the exact same way. We'll be passing in 1 plus the rest of the values. So this will be 2 through 10, and 2 through 10 will go up here. The x will now be 2, and xs will be 3 through 10. X will become 2 down here. 3 through 10 will be passed in here, and then x will become 3, and so on and so on and so on, until we get down to that point where we are dealing with just 9 and 10, and then those will be handled by our base cases, and that'll recursively return all the way back up until we can do 1 plus 45, or 54, and that'll give us 55. So if we do node Haskell JS, then we still get 55, and the answer being 55. Now, of course, like I said a few times, this is a weird way to do it. This is not how JavaScript seems to prefer that you write it. So JavaScript provided us with a lovely little method on the, I think it's on the object, or the array.prototype, which is reduce. And so, see how simple this is? You can take sum, which I believe the term is predicate function. Really what it means is just whatever function you're going to pass into your reduce. And we have our base case for handling if nothing is passed in. And then all we do is we return the array with the reduce method called on it, passing in sum and then our starting value. So if you remember back in our for loop, we had to make sum declared and assigned a 0 value. That's the same thing we're doing here. We need something to add to the first value in the array, which is 1. And so 0, when you're summing things up, is a perfect value to start with because it's essentially like it doesn't exist. So how does reduce work? It'll take sum, and it'll take the, or sorry, I should say it'll take the first value in the array, which we're calling reduce on. It'll pass that value plus, or that value and the initial value that you provide into this function that you provide. So it'll pass 0 in as num1, it'll pass 1 in as num2, it'll add them together, and it'll return it. So now it'll pass in that return value in as num1, and then it'll take 2 and pass 2 into num2, it'll add those together, and then return 3, which will be passed into num1. So this num1, in this case, becomes what's called the accumulator, and then this is the current value. So by the time that we get to 3, we'll be adding 3 plus 3, which will be 6, and then 6 will be passed into num1, which will be added to 4, and that'll be 10, and so on and so on. And once again, if we go node reduce, then we get 55, which matches our manually calculated answer of 55. So looking at this, it might not make sense just looking at it. All right, I get it, reduce, we're reducing it down a bunch of values to one value. But if you understand how we got there with these, from the for loop all the way up to some nice recursive stuff and into this reduce function, or reduce method, it should make a lot of sense how this is actually working. And reduce is extremely powerful. You can use reduce to compose functions together, where each value that you're passing in is actually a function, and those functions can compose into a larger function. You can reduce strings into single values. You can do a lot of stuff with reduce. So it's extremely powerful as long as you understand it. Anyway, guys, I hope you learned something. I had a lot of fun preparing for this video, and I hope that you at least enjoyed watching it. I'll see you guys, I think I'm putting out a video tomorrow on map, and that's sort of a cousin to reduce. I use these guys all the time, so I'm looking forward to talking about it. Have a good one. Bye.